Welcome back to Kamal Kunj Home Academy, Encounter with the Art and Science of Ceramics. In this session, we will discuss the significance of alumina-silica phase diagram in ceramics. This indicates this point temperature is in Celsius. Here is silica. Here silica is 100%. This point indicates alumina. Two, 3%. Let this temperature is 1400 degrees Celsius. Say 1600, 1800, this 2000, now in this binary phase diagram between silica and alumina, there are two Solidus lines. Number one starts from 100% silica and goes up to Mullite. There is only one binary compound, Mullite, which is formed in this binary system. Mullite, theoretically it is 71.6% alumina. This is the Solidus line which goes to Mullite. This is Mullite 3Al2O3 twice Si2. This Solidus line, first Solidus line at 1595 degrees Celsius. Melting point of pure alumina is 1710 degrees Celsius. This is Mullite and Mullite solid solution. Mullite is a binary compound of silica and alumina. It melts congruently at 1850 degrees Celsius. And there is Mullite solid solution. There another Solidus which goes from Mullite to alumina at temperature of 1840 degrees Celsius. There are two eutectics in this phase diagram. Number one E1 at about 10% alumina. First eutectic and second eutectic here forms at 77.6% alumina, E2. So as alumina percent increases from 0 to 10, softening point of silica goes down. Here first eutectic forms. As alumina content increases, solid phase also increases and liquid phase decreases. And here another eutectic forms. And melting point of pure alumina is 2050 degrees Celsius. So in this region, silica is in the form of cristobalite. Plus this is Mullite solid solution. This is Mullite solid solution. So it will be cristobalite plus Mullite solid solution plus some glass. Here this will be silica plus liquid phase. This will be liquid plus Mullite solid solution. This will be Mullite solid solution plus alumina and corundum. Mullite solid solution plus corundum. Here eutectic, when liquid is cooled, at this point it changes completely to solid phase, mixture of solid phases. And when temperature is just above this, at this point completely converts into liquid phase. And here as alumina content increases, liquid phase will decrease and Mullite percentage will increase. So here we see that when alumina percent increases up to 10%, its softening point of silica decreases sharply. So in silica bricks, alumina content should be as minimum as possible. For good quality silica bricks, for good quality silica bricks, alumina percentage Al2O3 should not be more than 1 weight%. And alkalis, total alkalis should not be more than 0.3% by weight. Now, as alumina content increases from here to here, liquid phase will decrease and mullite content will increase. So this phase diagram indicates the silica refractories. Here, alumino-silicate refractories, mullite refractories, and alumina refractories or corundum refractories. So when liquid percentage will decrease, its load bearing capacity at high temperature, hot load bearing capacity will increase, because hot load bearing capacity, which is indicated by two parameters. Number one is RUL. RUL means refractories under load. Refractories under load. And second parameter is HMOR. HMOR, hot modulus of rupture. Hot modulus of rupture. So, hot load bearing capacity of refractory is indicated by in terms of RUL value and HMR value. RUL or HMR value. Now, hot load bearing capacity depends on the hot load bearing capacity depends on number one, amount and nature of liquid phase. Amount of liquid phase, and second is the nature of liquid phase. That is viscosity. What is the viscosity of liquid phase and what is the amount of liquid phase? HMR value or hot load bearing capacity will depend on these two factors. So, as alumina percentage increases, liquid phase decreases, it means hot load bearing capacity will increase with increase in solid content or mullite percentage. And mullite compound melts congruently at 1850 degrees Celsius. So it is a very good refractory, having very high refractness and refractness under load. Here, from mullite to alumina up to 1840 degrees Celsius, we completely solid. Mullite, solid solution and corundum. So it will have very high refractness and hot load bearing capacity. Now, this phase diagram indicates this refractory number one, silica refractory. Number two, alumino-silicate refractories. Refractories where alumina is Al2 2, 3 less than 50%, and third is a high alumina refractories. High alumina refractories. L23 more than 50%, and Mullite refractories. Mullite refractories. For pure mullite, theoretically alumina is L23 is 71.6%, and rest is silica, SiO2, 28.4%. These are theoretical values. And fifth is alumina refractories or corundum refractories. So, with this phase diagram indicates some of the characteristics of these refractories. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.